Good morning, Algebra 2 class. As you can see, I'm not here. My daughter is sick, so I had to stay home. So nope, not coming in. But I do have some nice gifts for you. I left 2.5-ish worksheets, so we're going to go over those worksheets. So let's start with this one. Trigonometry prerequisites, special right triangles. So if we look at the first part, this right here is just a quick review of the special rules for the 30, 60, 90 triangle. Okay. So the hypotenuse, in this case, instead of using x, they use the n. That's 2n. And then the long leg equals a short leg times that. So what do they mean? Well, this leg is just n. And this leg is n times the square root of 3. That's the same pattern that we said. It looks a little funky there. It's the same pattern. And what they're saying is that because this leg is n times the square root of 3, it's longer than this leg, which is just n. So that's why they're calling this the long leg and it's the short leg. I never did that. I just had two sides. The side that is across, right, across or opposite the 60-degree angle is n times the square root of 3. The side that's opposite the 30-degree angle is n. So that's all this is saying. So now let's apply that stuff to what we got. Well, right here, I want to know what x and y are. And this triangle is a 30, 60, 90 triangle. Oh, wait, they're all 30, 60, 90. But we're looking at this is the 60-degree angle. Well, this is the 30-degree angle. And what side do I have? I have the side that is opposite the 30-degree angle. So that means it would be n. So in this case, n equals 8. Now, why did I do that? Only because I want to be able to relate to this chart right here, to this diagram. So y is the longest side. And if we know n is 8 and the longest side is 2n, then that would mean y equals 2 times 8 or y equals 16. And now we're looking at the longer side, the side that is across from 60 degrees. Well, that would put it at n times the square root of 3. Well, we know what n is. We just said n is 8. So then that means x equals 8 times the square root of 3. Now this half right here is similar to what we were doing on the unit circle. So I'll go ahead and knock this out and leave the rest for you. So I got a 30, 60, 90, yippity-doo-dah. The one value that I know is this 1/2 that is across from 30. That's 1/2. So then that means that x is 2 times 1/2 because it's 2n. And if n is 1/2, then this value is 2 times 1/2. Got a little ahead of myself. So I got 2 times 1/2. The 2's cancel off and I got 1. So x equals 1. So then I need to figure out what y is, the side opposite the 60-degree angle. Well, according to our stuff, across from the 60-degree angle is n times the square root of 3. Well, what's my n? My n is the short leg. It is the across from the 30th. Well, there's across from the 30th, 1/2. So I got y equals, y ends up being the n, which is 1/2, times the square root of 3. So what ends up happening is y is going to be the square root of 3 over 2. Because when you multiply 1/2 times the square root of 3 over 1, you get the square root of 3 over 2. You just multiply top times the top, bottom times the bottom. Bada boom, bada bing. So you should be able to do the rest of those. Now let's go to the second page or flip it. So what do they say here? Well, the hypotenuse is the leg times the square root of 2. That's the longest side. That is the leg times the square root of 2. Well, the leg equals the hypotenuse divided by the square root of 2. Well, what that just means is I'm going to cut the hypotenuse in half. I mean, no, I'm not. I'm just going to take the end. What am I saying? Woof. Yeah. So that's going to be my pattern is n, and n times the square root of 2. So let's look at this first one. It's a 45, 45, 90, right? Well, my n is going to be 8 because it doesn't matter which leg it is. They're the same length. So this leg right here is going to be 8. And then I need to get x falling in line with this. So it's n times the square root of 2. There's my n. My n okay. So I got 8 times the square root of 2. And that's my x. That's it. It is the leg, the n, times the square root of 2. That's the hypotenuse. Bada boom, bada bing. These all work the same. So what do we got here? Well, here we have a square. That's what these dashes represent. That all of those sides are the same length and all of these angles are 90. Well, then we have this line that cuts through them. It's kind of hard to tell, but that line right there represents like the perfect halfway point. So I'm cutting this thing in half. And I'm only going to pay attention to this triangle right here. So I got that going, right? And I know that my side is of X length. Ugh. So each one of these angles is 90 degrees, but that line cuts them in half. So guess what that does? That makes this a 45, 45, 90 triangle. And so what are my rules? The legs are the whole number, and then you take the whole number times the square root of 2, you get it. So that means that I've got n times the square root of 2, well, let's say x, equals 10. So then I divide both sides by the square root of 2, and I get x equals 10 over the square root of 2. Now, if you leave it like that, you get minus points because you cannot have a radical in the denominator. So I'm going to multiply top and bottom the square root of 2. So then that gives me x equals 10 times the square root of 2 over the square root of 4, because the square root of 2 times the square root of 2 is the square root of 4. It's like I was telling y'all before that remember what the most basic rules for radicals are is that if something's under the radical, it cannot interact with any other number that's on the outside of the radical. So when I'm adding, multiplying, subtraction, or division, they can't interact if one is on the outside of the square root and one is on the inside. So Those don't react or interact. So I got 10 times the square root of 2 over the square root of 4. Well, when I look at it again, I know what the square root of 4 is. The square root of 4 is 2. So now I've got x equals 10 times the square root of 2 over 2, because the square root of 4 is 2. But then I've got 10 on the top and 2 on the bottom. Both of those are outside the radical, so I can have those interact because a fraction is just a division problem. 10 divided by 2. So that's x equals 5 times the square root of 2. That's my answer for x. Now, we've got similar problems right here, but these are assorted, and you need to do these. So that's our first front and back sheet. Any questions? I don't know. Okay, so then let's go to our next sheet. All right, so what the heck is going on here? Well, they're giving us a quadrant plane, right? And they're saying draw the angle of the angle, the given measure. Determine if you are moving clockwise or counterclockwise. Which quadrant the terminal side lies in, the reference angle, and the positive and negative coterminal angles. Bottom line, we're not gonna find coterminal angles, so you don't have to worry about that. Okay, so let's do this one. 330. I know that this starts off as 0. This goes to 90. This goes to 180. This goes to 270, and then this goes back to making it 360. Well, 330. So that's 330 as far as my picture is concerned. So what quadrant is it in? That is the fourth. I guess I should have did this one first. It's going this way. That's counterclockwise because the clock goes this way. So what do we got next? So we got the quadrant is 4. We know that it's going um actually it's going clockwise. No, it's going counterclockwise, sorry. So we got counterclockwise and um quadrant 4. So what's the reference angle? Well, in quadrant 4, remember that the reference angle is 360 minus that angle that I just did. That angle that I just did was 330. So I take 360 and I minus 330 and I get my reference angle, which is 30. So now I'm going to do negative 210. Remember. Okay, so negative goes in this direction. Which direction is that? It's clockwise. Next, I'm going to plug in my little line for my angle. So I've got this is 0. Instead of going that way, because that's the positive direction, I'm going in this way. So this is 90. This is 180. This is 270. So I start right here. That's 90. That's 180. Right? I'm going in the negative direction. I'm going backwards. So I went 90 degrees, negative 90. Then I went negative 180. And we need to get to 210. So now that that's 180 degrees, hmm, Okay, so 0 to 90, 90 to 180. I want to go to 210. So 210 is going to be somewhere in here. Remember, it's negative, right? So we know it's going clockwise. That's clockwise. What quadrant is it in? It's the second. And then what's the reference angle? Well, we know that from here to there is 180. Well, that's not big enough for what we're doing. So here's my little triangle. And this ends up being, let's see, if this is 180, then I look right here, that's 210 minus 180. So the reference angle is 30. So how did I know that that was uh, 30 degrees? Well, like I said, 90 and then 180. So to get to 210, I had to go from 180 to there. Remember what the reference angle is. It's the terminal side with the x-axis. So reference angle is 30. I'll leave you to do these other ones. All right. So that is those two sheets.